Welcome. These are the topics which we are going to cover in this lecture. We are going to look at statements. What are the different types of statements offered by the C language? Then there is a type of statement known as if-else, which is used to make decisions in the C language. Similar is switch case, which is based upon cases. Okay, starting off with statements. We know what a statement is. A statement is nothing but a part of a program that does something, that conveys some meaning. So that is a statement. There are other type of statements. The most common type of statement is console input output. Console I/O. Console input output means, you know what a console is. The black screen. When you run your program, a black screen appears. So that is a console. And when you input and output from it, that is called console I/O statements. Those statements are all console input output, like printf or scanf. There are selection statements. Selection statements. Selection statements are nothing but they include decision control. What do you mean by decision control now? Let's say you have two statements, and based on some condition you have to execute either statement 1 or statement 2. So here comes making decision. Now these selection statements are used for decision control. Then comes iteration. Iteration statements are nothing but loops. They are looping statements. When you need to execute some statements again and again, so you employ iteration statements, which are nothing but loops. And there occur jump statements. Jump statements are used to transfer the control from one part of a program to another, to jump from one part of a program to another part of a program. Now let's see what is console output, then we'll see console input. So we have been using the most common function for console output. Yes, you guessed it correctly, it is printf. Printf, the function. Now you know what a printf is. We have seen the format of printf in previous lectures also. Let us quickly review that format so that you remember it more perfectly now. Printf, when you call printf to do your work, what you pass? You pass the first parameter, a combination of text, right? Text, format specifiers. Format specifiers, and there are some special characters known as escape sequences. This is new. We'll go through it in a while. Escape sequences. And then you have a list of variables. List of variable. So this is the format of printf. We know this format very well. Now let us look at format specifiers. Format specifiers. We have a lot of format specifiers. Let me list all of them and then we'll go through them one by one. We have %i, we have %d, then we have %f and %c. So what do %i mean? %i means an integer, right? We have used it. So do %d. So you can use %d or %i interchangeably. %f is for floating points and %c is for characters, right? Now there are other format specifiers. Let me again list every one of them. There is %s. There is $X or %x, and there is %o. Let us look at each one of them. What do they stand for? %s is for a string. Now instead of a single character, if you want to print a lot of characters, there is a data structure, there is a structure called an array. So if you have a list of characters, an array of characters, that is nothing but a string. Now for printing a string, you use %f. We'll let you know what a string is in later lectures. For now, remember that %s is for string. Now you know that we are in a decimal number system. We have 10 fingers, so we have 10 numbers, 0 to 9, and combining these 10 numbers we form a number system. There is another type of number system known as hexadecimal number system, wherein they have 16 numbers. They start from 0 to 9, and after that A, B, C, D, E and F. So they have 16 numbers, 0 to 9, 10, and A to F 5, A to F 6. So 16 numbers. So such type of number system is called hexadecimal. And to represent hexadecimal, you use %X or %x. It just converts this integer into hexadecimal and displays it. Similar to hexadecimal, there is octal, wherein that number system has only 8 digits, 8 symbols to represent numbers, 0 to 7. So this is for octal. %O is for octal. Now enough with format specifiers here. Let us look at escape sequences. What are escape sequences? Escape sequences. Now escape sequences are nothing but special characters. They are special characters. Like, what are special characters? Like tab or new line. When you press enter, you actually enter a special character known as a new line. So these are special characters. If you want to print special character, you use escape sequences. Now let us look at what are the different types of escape sequences. As I said, escape sequences are used to print special characters. So you have a new line character, a tab character. To print a new line, you use \n. To print a tab, you use \t. Remember that this is a backslash. For backspace, \b. For backslash, if you want to print a backslash, so you have to use 2 backslashes, because if you use 1 backslash, it will confuse the compiler or the printf function that is this an escape sequence or a backslash. For a single quote, you have to use \single quote. For double quote, \double quotes. And there are many more other escape sequences supported by the C language. Now escape sequences always start with a backslash. Remember, we used the new line character in our previous lectures to go to the next line, and any escape sequence is considered a single character, although it contains 2 characters, but the C language considers the escape sequence as a single character. So remember that it is enclosed in single quotes, right? Any single character is enclosed in single quotes. Now how do you use escape sequences, escape characters? So let's say you have printf, my name is John, and before John you have \n. Now how will be printed? The output is as shown, my name is, and once it encounters a \n, it goes to new line. So new line and then John. Let's take another example. Printf, the price is \t 500. Now \t is a tab character. So you guessed it correctly that there is a tab space wherever it finds \t. Printf hello \b \b. Now \b is for backspace. So let's see the output. He, man. So we have hello and then 3 backspaces. So it goes back. It deletes O, deletes L, and deletes another L. So he, and then prints man. So the LLO is omitted and then man is printed in place of that. For a single backslash, you have to use two backslashes, because if you use a single backslash, like in this, my name is backslash n John, if you use a single backslash, the compiler, the printf will confuse itself that the number, the letter following the backslash is an escape character. So you have to use two backslashes. Backslash, single backslash. For two, you get one. If you want to use a single quote, then also you have to precede that with a backslash. So the output will be this: name Guru. If you have printf programming, so you have to use a backslash and double quote for a single double quote. Because if you use just double quote, it will end that string, right? So this is how programming is printed. Okay, now comes console input. So we have the most popular function for console input as scanf. Right, we have used scanf. Let us quickly review the format of scanf. So to call scanf, we write scanf, and then we pass it as the first parameter format specifiers. Format specifier. And then we pass a list of variables. List of variables as the subsequent arguments, as the subsequent parameters. But we not only pass it the format specifier and a list of variables, actually it needs addresses of variables. So we have to precede every variable with an AND operator so that it gives the address. Okay, let us take this example of scanf. Scanf %d, we have to print and we have to take input an integer, so we have used %d instead of %i. Both are same, so used %d and address of n. So we have to take input and put that value into the variable n. So let us analyze each part of this scanf. So this %d is nothing but a format specifier, as we know. %d or %i for int, %f for float, %c for char, and other format specifiers which we have discussed can also be used. This AND is an address of operator. It gives the address of variable in the memory. Right? A variable needs space, and wherever in the memory it is allocated the space, AND operator gives the address of that space, of that memory allocated. And scanf always needs the address of variables. It is a common mistake that people drop the AND operator, but always use AND operator while you use scanf. It needs addresses. It does not need the variable's value or the variable's name. Now one thing which is very important is that within these double quotes, the first parameter, no text is allowed. Only you are permitted format specifiers. We have drawn this, we have written this, that in double quotes you have format specifiers, no text. So if you write scanf, enter the number and %i, that is wrong. It can take multiple inputs. Scanf can take multiple inputs. If you write scanf %i, %c, you can have multiple format specifier, which means that it will take multiple inputs from the user. So scanf %i, %c, and then we take input the value of two variables, age and sex. Okay, now let us move on to selection statements. If you pay attention to the word selection, it means that selection of some statements based on some condition. So it selects statements based on condition. Right. Now you have two selection statements available in the C language. The one is if-else construct. If this, else that. And another is switch. Now let us look at this, each one of these. So first we'll look at if else, right? So let me draw a flow chart here. Based upon that flow chart, we'll explain what is if else. So you have statements, in a program, statements. Then you go on executing statements, and then you have a choice between two blocks of statements. So you have one block S1 and another block S2. You have choice between these two statement blocks, if some condition, based upon some condition, and then either execute this or this, and then continue with executing other statements, right? Now you go on executing these statements, and as the control executes statements sequentially, it encounters a condition. Now here is a condition, and your condition is that if this condition is true, then execute the statement S1 and then go back to other statements and follow the ladder. And if this condition is false, execute S2 and follow the same path to other statements. So you are making a decision between S1 and S2 using if else, using a condition. Let us take the example which we have written earlier. We have drawn a flowchart of this example. Which number is greater, A or B? Let us draw this flowchart for our problem. Okay, this is the flowchart of our problem. We take input A and B, and then we have a condition. Is A greater than B? So if this condition is true, that it is true that A is greater than B, we print A is greater than stop. If this is false, which means that B is greater. If A is not greater than B, then B is greater, and then stop. So let us write a program for this problem using the if-else construct. So the first and the foremost thing we have to do is to include the standard input-output header to make printf or scanf work. So we have #include stdio.h. Then our main function, void main, so first thing we have to do is to declare variables, right? So int A and B. So we are declaring integers A and B, right? We have declared them. Now we ask the user to give us the input. So first we ask printf enter A and B, and we ask this, then the user enters A and B, then we scan that input, scanf. So all are integers, so %i, and then we provided the addresses of A and the address of B, right? We have done this. Okay, now let us go back to our flowchart and try to infer something from that. If you look at this, it says that if A is greater than B, if means true, if A is greater than B, then print A is greater. Else, that means if A is greater than B, this condition is false, we say B is greater. So let's try to implement this into our program. So we had if A is greater than B, then what we do is we have an if block. So the syntax of if else is if, and then within parentheses you have conditions A and B, then you have the if block. So in the if block, if A is greater than B, then we printf what we printf is a is greater, right? Let us make this code aesthetic. We enter a new line here, then else. If this condition is not true, if it's false, if the condition is false, then the control goes in the else block, and in the else block we print b is greater. Printf b is greater, \n. So this way our program is ready. So this is what I got when I ran this program. Enter a and b. Let's enter 5 as a and 4 as b. So it says that a is greater. Indeed, 5 is greater than 4. So our program is running perfectly. So if a is greater than b, printf a is greater, else b is greater. And you must remember that if has a block and there is an else block bounded by these braces. Now you have only one statement in these braces currently, but you can have as many statements as you want. But a question that arises is, can you drop these braces? And the answer is yes, you can drop these braces. But the condition should be that if there is only one statement. Now let's go back to our program and see that if it's only one statement. Yes, there is only one statement, so you can drop the braces. Now this program also works the same as the previous program, because as we have dropped the braces, we can drop the braces if there is only one statement. Now if you have if num equals to 1, printf 1, there is only one statement, you can drop it. If you write like this, if age is greater than or equals to 60, if you have a condition and then you have two statements but you have not used the braces, it means that the second statement does not belong to your if block. Only the first statement belongs to your if block if you have dropped the braces. So if you want to include that in your if block, use the braces. Okay, now let us quickly review the syntax of the if-else construct. Firstly, you write if. Now if, then there is a condition. Condition. If it's true, if the condition is true, then you execute the statement in the if block. Execute this statement if this condition is true. Else, what you do is execute another statement in the else block. If the condition is not true, if the condition is false, then execute this statement. Right? This is usually the syntax of the if-else construct. One important thing here is that you can drop the else part also. You can have only the if part, drop the else part, because there are situations where you have to execute some statement only if a condition is true. You don't have to execute some statements if the condition is false. So if such is a case, you can drop the else. No problem, you can drop the else. Now another question that arises is that can you have if else inside if else? So if else inside of if else. So this concept is known as nesting of if else. Like you have nesting of comments, you can also have nesting of if and else. Let us demonstrate this using a program. Let's say we have a program that says it is a number to word service. Number to word service. Just to give you a slight example, when you input 1, it outputs ONE. In words, you give it a number, it will tell the word of that number. So if you have 2, it will say 2. For simplicity, we keep this until 5 only. So if you have a number greater than 5, it will not give you any answer. So 1 to 5 it can give. Let us now go back to writing this program. Let's write this program actually. So as this is the compiler window, remember that we have hash include stdio.h, then we have void main. Now inside this we start writing our program. So first of all, we will ask the user, printf, please enter your number between 1 to 5. First of all, we'll title our program. Let's say we'll print number to word service. Right, you have the title. Then in the next line, remember we have used a \n. So in the next line, printf will ask him to enter number between 1 and 5. So we have asked the user to enter a number between 1 and 5. Then the user will enter a number, so we scan that number. Scan that number, it's an integer, so %d or %i, whatever you like, and scan that into some variable. So let's say we have the variable num, so we pass it the address of num. Oh, we haven't declared num, so let's declare num, int num. So it scans num. Then we check each time, right? If the number is 1, we print 1. Else if it is 2, we print 2. Else if it is 3, we print 3. So let's put this into working. So if num is equal to, now here comes relational operator, is double equals to, if it is double equals to 1, if it is equal to 1, then we print, okay, let's put this in if block, printf ONE 1. Right. Else if the number is not 1, what we do is we check that if it is true, if again num is equals to 2, again we have the if block, so printf TWO in letters. Else if the number is not 2, then again in the else part we check if the number is 3. So we go on doing this until we reach 5. Printf 3. You see, we are forming a ladder of if and else. We are nesting if and else. Else if, again we check that if it's not 3, it must be 4, because we have checked 1, 2 and 3. It is not 1, 2 and 3, it must be 4. If num is equals to 4, then print that it is 4. If not, print 5. Printf 4. So if it is not 4, we assume that it must be 5. So else printf that this is 5. Now this is what I've got after running this program. It says number to word service, enter any number between 1 and 5. So let's say we enter 3 and press enter. Yes, it says 3. So our program is running, but the problem here is that after you nest if and else, you seem to mismatch the if and else. Look, there are so many ifs, so many else, and the structure of the program is not pleasing to the eye. You have to match braces here. This brace matches with this brace, and so it becomes quite untidy. So it is difficult to understand also. Now, to remove these difficulties and this matching of braces, which are very difficult, there is another construct known as if else. Now let's look at what if else is. It is used to remove nesting. So let's modify this program according to if else concept. So this is if number is 1, then print 1, else, and then inside else we have if. So we can combine these. If else if num is equals to 2, then we print 2. So similarly, else if num is equals to 3, we print f3. So this way it gets quite cleaner and quite easier to understand. If else, and it makes the program quite tidy. And note that we don't have to match so many braces, so we remove these braces. Now our program looks quite simple, and if you read this program, it does make sense. If num is equals to 1, printf 1, else if num is equals to 2, printf 2, else if num is equals to 3, printf 3, and so on. So our program is quite simple and good looking now. Now if you run this program, it also runs perfectly the same as the previous one. So let's say we enter this time 2, and we got 2. Now let's look at the syntax of if, and else construct. So if the condition is true, then you have to execute this statement. Else if another condition is true, you have to execute this statement. And else, otherwise, if both the conditions are false, you execute this statement. Now remember that else is also optional in this construct also. So you have if else and if else, two type of if else. Now if one condition is true, if it checked if this condition is true, if this is not, then it goes to the other else. Once a condition is true, then the other conditions below that, the rest of the else ifs are not checked. They are directly skipped, similar to a kind of if, another else if, right? That's the case. Now you can use logical operators in the conditions which you provide to if and else's. Let's say for checking range, let's say we have this program hash include stdr.h void main. We have dropped main here for simplicity purposes. You have to include void. Now you ask the user to enter his age, and you scan that age. You have declared a variable integer age. Scan that variable age. Now if his age is less than 18, you do nothing but you print that you're minor. Else if the age is greater than 18 and the age is less than 40. So you are checking a range. If the age is between 18 and 40, you print that you are an adult. So thus we are checking the range here between 18 and 14. Look, we have used the logical operator and. So it just means literally, if age is greater than or equal to 18 and age is less than equals to 40. According to the truth table, if this comes out to true, these two expressions, then it will go ahead. Again we are checking if the range is between the age is between the range 40 and 60, then printf middle age, else if print retired, right? So we are combining conditions using logical operators. Now it is advised to use parentheses. If we take an example, if age is greater than or equals to 18 and age is less than 40, now you are checking a range here. So if you use parentheses, it makes much sense, right? And it removes confusion between the programmer. If you write a program like this using the upper approach, then it is likely to cause problem for other programmers who read your program. They might not understand, they might not know the priority, so they might get confused which will be executed further. So normally this is executed further and this is executed further, and then these are executed using, these are operated using the AND operator. So it goes ahead, and what you are doing is you are parenthesizing the expressions, right? It is much better and it is not confusing, you know. Now before we look at common pitfalls, let us look at something else which is quite interesting. So in C you have two things, true or false in logics, right? And specific to the C language, true is always represented by positive or negative values, that is non-zero. Truth, right? Truth is always non-zero. And if a value, if you want to represent false, you represent it using 0. So now let us look at the common pitfalls in the C language using the if-else constructs. Now a common pitfall is that you use assignment operator instead of the equality operator. Let's take this example. Here you have used assignment operator. Actually you wanted to check that if n is equal to 5, but you have used assignment operator. What this statement will do, that it will assign 5 to n. It will not check the equality between them. So what it does is n is assigned the value 5 and there is only 5 in if. Now what we've learned is truth is always non-zero. Now this is non-zero, 5 is non-zero, so it is always executed. So whenever control passes through this if, it is always true. So this 5 will always be printed. Condition becomes always true. What to do is nothing but replace the assignment by equality operator. Another common pitfall is the semicolon after the if statement. Sometimes what you do is you have corrected the assignment operator, put the equality operator, but sometimes you place a semicolon after the if. Now semicolon semicolon denotes a null value. It denotes nothing. It denotes an end. So it is expanded like this: if n is equals to 5, semicolon. Remember, the first statement is always in the if block if you don't use blocks. Now this 5, printf 5, goes out of the if block. It is some other block. Now semicolon is null terminator and it is inside if block, this I've told. So you should remove this semicolon. Okay, now let us learn something about cases. What are switch and cases in the C language? Let's go back to our previous program which we have learned, which we have written this if else program, this number to service. If number is 1, print 1. If number is 2, print 2. What you can observe from this program is that this variable num has cases. It has 5 cases: 1, 2, 3, 4 and 5. So let's sum this up. So this variable num it has 5 cases, right? 1, 2, 3, 4 and 5. If its value is 1, if its value is 2, if its value is 3, if its value is 4 and 5. Okay, what you do is, if its value is 1, you print 1. We have done this. This is 2, 3, 4 and 5. Now we know that these 1, 2, 3, 4 and 5 are cases for num. Now what you can do is select this num, take this num and try to determine what are the cases of that num, and according to that case execute some statements. For this, the C language provides you the switch case construct. You have the switch case construct. Let us convert this program using a switch case construct. Now let's remove this. Now remember that the num has to be selected. It has to be switched between the cases, right? So first thing we do is we write switch. Switch. Which variable is to be selected? So switch num. And then we have the switch block and write the cases for this num. So we have case 1, we have case 2, case 3 and on and on and on. So I've written all the cases. Now according to these cases we execute our statements. So if the case is 1, we printf 1, right? And the same with other stuff. So this way we can clean up all of our program to some smaller programs and quite easier to understand. So num has cases 1, 2, 3, 4, 5, and based upon these cases we execute statements. If the num's value is 1, this statement will be executed. If it's 2, this statement will be executed. Now let's run this program and check what output does this give. Now let's enter number between 1 and 5. Let's enter 5. And it says 5. Press any key to continue. Now our program has executed correctly for this case, for the case 5. Let us run this and try it for case 3. If we enter 3 this time, look what the magic happens. It has printed 3, 4, 5. So let's go back to our program and try to determine what went wrong. So the control was first here, it switched num, it selected num, and then determined if its case is 1, if its case is 3, if it's 2 or 3. It then found out that the case is 3. So the control went here, printed 3, and then came down, printed 4, came down, printed 5, and went away. So what happened is, when a case is selected, all the cases below it are also executed. Why? Because we have not stopped the control somewhere here. After the case, we have to stop the control. So how do you stop the control? You stop it by applying breaks, right? So we apply a break statement here. A break in every case. Whenever a case gets over, we have to apply a break statement so that the control does not go to next cases, it goes directly out of the switch. Here also break. Now the last case does not need a break, because eventually anyways the control is going out of the last case, right? So no need to apply a break. Now let's run this program and see if it works or not. This time let's enter 4. Let's enter 2. And this time it works correctly. It has not fallen down the cases. Okay. So let's analyze. The control was here. First num has been selected, and then it goes to the second case, executes printf2, then encounters a break. So it does not execute these three cases. It goes directly here, out of the switch. Now comes the question of the syntax of the switch case construct in the C language. Now how it's written. Firstly we write switch, and then which variable has to be switched. Here only a variable or a constant can be there. It can also be an expression. So here some value has to be there inside the switch parenthesis, and then you have cases for these values. Inside the cases you should have only constants. Only constants are recommended, though you can have expressions, but they should not give some arbitrary value. Those values should be constant. So recommended that you should have constants in the cases. And remember that you need to break every case. You need to come out of every case, so that when a case is executed, the control does not fall down to respective to the lower cases. And one more important thing remains is the default case. Default can be written anywhere. Mostly it is written on the lower side of the switch. Let me put a break here because it should not fall down to default this time. So default is in the last end, is the last case of switch. Default means if the value of num is not any of the cases, then it will execute default. Let's say if the user enters values other than 1, 2, 3, 4, 5, we can say that we can ask him that please enter a valid value, right? Then \n. So let's run this program and check whether it works or not. Now let's enter an invalid value. Let's enter 100. It says please enter a valid value, right? So what has happened is that if the value of num does not lie in any of the cases, it will execute default. Now default is optional for switch case. Okay, now switch cases have a lot of advantages. You can write a menu program, a program which involves a menu using a switch case construct in the C language. A menu program like this. It says, it gives us a menu, A for multiply, B for divide, C for exit. If you enter your option as A, it says multiplying and says thank you. So this way you can implement a menu program. Let us know how we have implemented this program. I've already written the program for you. You just have to sit back and watch. This is a menu program. First thing, we include standard input-output header file. Then we print our options A, B and C, multiply, divide, C for exit, and then ask the user to enter his option. When he enters his option, we scan his input into a character variable. Now A, B and C are characters, so we have to input them in character format, right? So the format specifier we have specified is %C and the address of this character variable ch. Now based on this character variable, based upon its cases, which values it can have, A, B or C, we do the printing, we do the operations, right? So we switch the character ch switch ch, and then we have the cases, capital A, capital B, and capital C. If the case is A, we printf multiplying and then break. If the case is B, we printf dividing and then break. If the case is C, that means exit, we do nothing but return. Now there is no need of break because the program is exiting, then there is no question of the other cases being executed. So we just return. We return from here to the operating system directly because we are in main, so it will be returned to the operating system and eventually the program ends. Now if the user enters some wrong option, so we'll say that invalid option, please enter again. Then at last we say thank you. So let us run this program again and see what are the small errors that have crept into our program. Now if I enter capital B, right? If I enter capital B, then our program works perfectly right. Again, after rerunning this program, if let's say I enter, instead of capital B, I enter small b, because people tend to use small letters instead of capital letters, even though they see those capital letters. So if I enter small b, look what happens. It says invalid option. Although I have entered a valid option, according to human beings, we tend to equate capital B and small b as same. So it says, but the computer says that it is an invalid option, because in the C language capital letters and small letters are different. So how to fix this? It's so simple. I told you that if you do not apply breaks to cases, the control falls down to the lower cases. So let's use that disadvantage of switch case as our advantage. Look what I write. Case small a, and here I write case small b. And for the last case I write case small c. So what I've done is, before the capital A I have written small a case, but I have not applied breaks to this upper case which has small a. So whenever the character has value small a, the control goes here instead of going here. But as it goes here, it automatically falls here and then prints multiplying and then breaks. So the idea is simple. The idea is that when you don't apply breaks, the control falls down to lower cases. So in this case we have used it and it has been advantageous to us. Let's run this program and check if this works or not. Now this is our program. Let's enter small a, and this time it has worked perfectly. So this is how you program using the selection statements in the C language. We have if-elses and we have switch case statements, and in my opinion I think these are pretty easy, and you can create quite large programs using these two constructs.